You can keep talking about it.
Yeah.
It's fine. Okay.
AB, thank you for doing this with us. This is great. I'm pretty excited.
Oh, thanks. Always a pleasure. It's always good to give back something, and it's good. Yeah.
Yeah. Oh.
And it's simple as well. And it was like one of my first experiments as well. So dlib is very close to my heart. So it was a very good experiment. And I would to give a shout out to the PyImage search blog as well. So it gives you a good starting point for a person who is not at all like comfortable with computer vision and all that stuff. So it gives you like high level overview, and then there's a nice documentation, and there's a blog from Satya as well, which is very, very good. It goes into details as well.
Yep.
So like a good mixture. So I think I would definitely recommend, I will make a mention in the Hacky Hour as well.
Yeah, you should. Adrian's stuff's wonderful. So
yes.
Okay, AB, Steve, we're gonna get started shortly.
Okay.
Okay, hi everyone. Welcome to Always Coding, our weekly hacky hour. I'm Komal Devjani, a developer advocate at alwaysAI. So these hacky hours are designed to have an interactive communication, an interactive session between our community of developers and our engineers internally, as well as some presenters who join us. So here you can ask questions about the topic at hand, or maybe questions relevant to something you're working on, or feel free to share with the community what you're working on, or share some ideas, and let's be interactive and conversational. So if you have anything to say at any point, or if you have questions, feel free to raise your hand, and we can take a break and call on you and kind of work it out from there. So
hey, Kamal, can I say one thing? So we have AB today demonstrating, but this is developers forum. So we hope that AB's it's the start of getting people to come on and show the different projects they work on. We'd much rather see that than actually even us doing presentation. So first of all, AB, thank you for that. And then anybody else, feel free to go ahead and email us and so forth, and we'll get you set up to do the same thing. So that's what we like to see, the community doing it. And thank you for being the first person, AB.
Thank you, Steve.
Yeah, I share that sentiment with Steve. I really appreciate you doing this with us, AB. So welcome and thank you.
Thank you.
I will actually give a formal introduction for AB right after we set up and just go through the setup process. And then I'll hand it over to AB to go over facial recognition. So going back to that, today's topic is facial recognition, and AB is going to demo an app, facial recognition app using dlib and alwaysAI. But just to set everyone up, I'm going to be sharing this app that Steve created a couple of weeks ago, and we presented this as well. And I'm just going to get started by showing you how you can do real-time facial landmarking with points, like critical points across the face. But first, let's get started. What you want to do is make sure you're signed up for alwaysAI. If you're not, go to alwaysai.co, and you will have the option to sign up where it says dashboard here. Once you're signed in, you will be navigated directly into the dashboard. And what you want to do is maybe you can start with a sample project or try out some of our popular starter apps. But the critical thing to do here would be to install the CLI. You won't be able to get very far with alwaysAI without this process, so it's very critical. So you can just click this CLI install instructions, and it'll give you opportunity to select your operating system. So it can be a Mac, Windows, or you could choose this if you're using Linux. I'm of course using Mac, so we're just going to hit next and then hit download for Mac OS. And with that out of the way, let's go ahead and just demo this repo that Steve created. So what I want to do is I just want to clone this repo. So let me pull up my terminal and I'll open a new one. And then here, I'm going to go into this directory that I've created for alwaysAI demos. And then let's just make sure I haven't downloaded it already, and I haven't. So we're going to git clone and paste the address that I just copied on GitHub. So this should take a couple of seconds to download. But when it does, we're going to run real-time facial landmarks as it's listed here. And then you'll be able to see the critical points on a person's face. And I believe, Abe, you're also using a overlay, right? To show how someone can add masks.
Yes. So yeah, I'm gonna demo two parts of my Hacky Hour. One will be related based on the app that Steve created. So facial landmarking. So on top of that, I can use overlays, and using the same library dlib, how we can do facial recognition. So I'll cover that. Yeah. And
Okay.
basically the application is a part of the same repository as a pull request. So yeah.
Great. Great. Okay, so let's just run this quick demo. So we're going to go here and then let's go into facial recognition, facial landmarks, actually. And then let's see, we'll do the CD real-time facial landmarks. And then from here, what we can do is AI app configure. And if you've seen me do this in the past, you've seen that I can create a project using the dashboard feature. But with this on the CLI, you can also create a new project by hitting the down arrow and then hit enter on create new project. And then we can title this facial landmarks. And once that's done, we want to save this to our local computer. And then from here, we can go into AI app install. And then AI app start. So you can just try this out, right? I've shared the GitHub repo in the chat section, so feel free to check it out. And let's see if this works. And yes, you can see this can detect critical points on my face, so like my nose, my eyebrows, my eyes, my mouth, and my jawline all the way around. So AB is actually going to build off of that and show you how you can use this exact functionality for facial recognition. But I believe a formal introduction is in order for AB because he's a very accomplished person. So AB is a software developer at Accenture, the Dublin, Ireland. He's an accomplished architect and a programmer with more than 14 years of tech experience. He enjoys using his skills to contribute to the exciting technological advances that happen every day in the field of cloud engineering, AI, and IoT. He holds a bachelor degree in information and technology. AB has built cars ranging from very small to a fifth size with teleoperation capability. He worked on building a bespoke chair for an Alzheimer patient with capabilities to play his favorite music, radio, and an AI voice assistant. And it got showcased on national television series in Ireland. He has been a mentor to kids to help build toys using robotics and simple scientific principles. He's obsessed with all tech-related things and spends his free time building cool gadgets and developing software. AB enjoys watching sci-fi, mysteries, and thriller movies, listening to Indian classical music with his son, and eating Indian delicious food cooked by his wife. Sorry about that. But yeah, so AB, go ahead and take over from here.
Thanks, Komal, for a very good introduction. Yeah, that's it. I'm a bit foodie. Yeah, I love eating food and doing stuff. Yeah, that keeps me going. And oh, thanks for having me here. So yeah, I'm gonna show you today two parts. Can I share my screen?
Try now.
Okay, great. Okay. Okay, so taking from the demo which Komal showed, the dlib facial landmarking, and basically what that thing was a 68 point. The webinar nicely covers, which was delivered 2-3 weeks back by Steve. So it is a 68 point shape landmarking thing. So if you see, the number ranges from 1 from here up to 68 somewhere here. Yeah. So can you see my cursor, Komal?
Yeah, I can.
Hello.
Yeah, can you hear me, AB?
Yeah. Can you see my cursor, right?
Yeah, We can.
Okay, cool. So it's ranging from 1 to 68. So this is the full facial points are marked as well. So which is gets put on any face which this works, and this works without any neural nets or something. So this is plain stuff, a library built by Davis King. So it is a very interesting library, and based on top of that, a lot of applications has been built. One of which was overlays, and other one is a facial recognition. So let me start with the facial overlays. I hope, Kamal, can you put in the GitHub repos in case people want to
Yeah,
refer it
definitely.
as well? I'm gonna show it here.
Yep.
So this is the repository. As you can see, it is forked from the same alwaysAI facial landmarking dlib repository. I just added another folder in there called facial landmarking overlays. This is what we're gonna cover today as well. So let's see it in action. So I'm gonna clone the facial landmarking repository. So what we're gonna do is it will take the it will take the same camera feed and try to put some overlays. So overlays are like, you can say, it will, in this example, I'm gonna try to put an eye patch on my one of my eye, left or right, which perspective you see that, and then I'm gonna push the mustache as well to see how it looks. If you guys are familiar with Snapchat filters or something, it's something like that. So it's pretty much fun. So you can even modify this code, and you can use it in a mirror. Like Halloween is around the corner, so you can make build some mirror with for Halloween. So if you go to facial landmarking dlib, okay, and then we go to facial real-time facial overlays. So you do the same alwaysAI AI. So I'm going to create a new project. Facial overlays. So it's the same thing which Koma already covered. So I'm going to run it on my local laptop. You can always run it on any edge device as well. You can run it on Jetson Nano or on Raspberry Pi as well. dlib, and if you want to speed up this further, you can have dlib compiled in the form of for enabling CUDA. That way, it will be faster as well. So if you see here, there's no there's no models required for this kind of thing. So it is plain using dlib and OpenCV. And you can start. So you have the streamer. You copy the streamer in the browser. And you see here. So you can see my mustache here, and you can see an eye patch on my left or right, whichever it is based on the perspective. So you say this, so it detects my eye and accordingly places the eye patch. So let me go through the code so that let me show you how I build this. So it's pretty decent FPS as well. So you see, it's very good, well, very fast. So this is the same code which the Steve's repository has that. I just added some of these pieces here. So some of the images to overlay. So I have this three images there. There's another part which you can work on this similar code basis. Instead of placing an eye patch, you can try to place some glasses on that. And that has a lot of real world applications. For example, if you're working, if any e-commerce site is selling glasses, so how that glasses look on you. So something like that. So, so this is the images. Then you create the mask for this, for the overlay. And we do a bit my own, this same OpenCV stuff. So basically how we can try to have that make a transparent background so that it can be placed very nicely, because the images are here. Let me show you how the images look like. So the overlays folders has all the images here. So if you see, they are all PNG folders. So these are actually transparent because PNG. So JPGs are more like, you cannot have transparent, you cannot have create overlays with JPG because they have a white background or something. So this is the glasses, and this is a mustache. Okay, so going back to the code. Oh, so we try to find the dimensions of how big we have to scale those images to based on the size of the face, right? So we have to calculate the size of the eye. So the easiest, simplest algorithm is that there's something called Euclidean distance based on that, and there's a algorithms called convex hull. This is a plain OpenCV stuff which we have used, and these are some of these functions. I'm just trying to focus on the functions which I added rather than going to the details of the earlier one. I will definitely can go through that, but I'm just trying to set the stage with all the helpful functions first. So where we can place the eye patch. So we have to see where the position of the eyes are. So you can even put the eye patch on both the eyes, or if you want to place the specs, so accordingly calculate where your eyes reside, and the specs should exactly be in the middle so that it aligns with your nose. So that's a different code here. So it's a similar code, but you have to do some additional considerations to when you're placing the glasses. And the other one is mustache. So let me go back to the earlier image which I showed. So you see the mustache always lies above the upper lip, and which is aligned to the nose, to the nose line between the range of 32 and 36. So if you see here, so this mustache should be within this range. So I set up that as a boundary, and within this, and this mustache should light here. Then I try to calculate what should be the width based on what is the face size. So something like 3 times the nose width or something. So like if you want to have a bigger mustache, so you just increase the offset from 3 to 4 or 5, whatever. So, and then you do the same stuff. You resize the mustache based on whatever scale you have, and then you place it or mask it on top of that. So in the main, it's the same HIQ way you write the code. Is like you instantiate the FPS counter, and you load the shape predictor, and then you start an instance of the webcam and the streamer. So let the camera warm up, and then we start the FPS counter. And once we read the frame, we get a NumPy array from the reading the frame, and based on the based on the face landmarking class, we get what are the coordinates of various based on whether it's the left eye. So based on the landmarks here defined. So we have to find out where is the left eye, where is the right eye. We have to pass on the coordinates to calculate the size of the eye. So once we have, so since I'm placing the, if you want to place the eye patch on both the eyes, for example, then you have to uncomment this code, and then it will make it happen. Another exercise, what I'm going to do here live is I'm going to try to remove the eye patch and try to put glasses on top. So for glasses, I have to uncomment both of this code because the glasses go on both the eyes. You uncomment this code, you comment this code, and you uncomment this code. So that way, so you will be placing glasses. We are sending the coordinates where the right eye and the left eye resides. And that way, let's see what happens. Any questions so far?
No questions yet, but I think it's great that there's like multiple utilities to this specific application. Like you can use it for Halloween, since you're not allowed to go trick-or-treating or like meet people right now. But you could also use this for an e-commerce site, like you mentioned, and help sell glasses or makeup or mustaches.
Very good.
So this is the simplest application of facial landmarking. So this is all good. See, tries to tag that. So there are some companies. There's one company. There's a company which is selling glasses, and I've seen that. So they create a 3D. So they I don't think they're using 3D. They create a 3D hologram. They ask you to align your face in a space. And then you turn left and right, and they try to create a 3D hologram, and then it tells you what are your sizes and frame sizes as well, because it tells you to put a credit card on top of that to measure the size of your distance between the center of the nose and the end of the eye, and based on that they calculate the size as well. So it's pretty there's a lot of applications in this kind of thing. Before we move to the next one, any questions?
None as yet. Does anyone have any questions? Feel free to raise your hand, or you can use the Q&A button to type out your questions.
They do want to know what editor you're using. So they're interested in your IDE and what code. I told them you were in Python, so they want to know what IDE you use. So I think
I use
right?
the plain VM editor.
Yeah.
So I'm.
But Vim is quite popular.
Yeah. So for me, like the Visual Studio Code is a very good editor if anybody wants to start. So it's it's a very good editor. It's very light, and you can use Vim in Visual Studio Code. So that's very cool as well. So I like that. So. All right. So now let's go to the thing which is more interesting, facial recognition. So let me go back. Okay. So the next demo I'm gonna talk about is about facial recognition. So the facial recognition repository is here. Komal will post that in the chat. So what we're gonna do here is about facial recognition. We're gonna have a known set of people, and we're gonna train, we're not going to train, we're going to extract the facial features of these known people and try to create a database of known people. And then we're going to run an alwaysAI app with a set of images of known as well as unknown people, and try to see if this program recognizes and tries to put a bounding box and label the person. So this can be definitely used as a first step for your facial recognition project. So there are two things. So people sometimes get confused with facial recognition and face detection. There are two different things. So face detection is just detecting faces in the picture, in the frame. And facial recognition is like you have a predefined database of people you want to recognize. It will identify Komal or Abby or Steve, and that definitely it can be provided as like your authentication based on that, or something on action which will be only authorized to be done by that specific people. There's a lot of use cases in IoT for facial recognition. There's a lot of in anywhere wherever you require authentication, so it can be add a layer to to your uh, to your application. But
We've
for this
also sorry, AB, I was just going to say, we've also seen a lot of, especially in China and so forth, where the POS systems also would like to integrate it in and trigger the CRM systems and so forth. So there is also that phase of facial recognition. So not only from the security element, but from the customer recognition side. So apologize for doing it, but it's another use case.
Absolutely. It's like to return. So you can see like in retail scenario to identify a loyal customer, and based on that, you can derive some insights based on that customer, based on his shopping history. You can give him some incentives or offers and right straight on his mobile phone, maybe on the app. So yeah, countless applications. So for the starters, like this is a very good way to start if you don't want to train any models, or if you want to do a simple POC as well, or built on top of this is a good starting point. So there's a very good library which I have linked into the repository called Face Recognition. So which uses the dlib state of art for to do this facial recognition. The principle is very simple. So what it does is it tries to extract all the facial features. So your facial features are unique to yourself. And if you give them more images or more data, it will try to create a set of that person. For example, if I give 5 images of Jerry Seinfeld, and whether from his young, when he was young, and what he looks now, it will create a set of Jerry Seinfeld, how it looks like in different stages. So it knows that, but that will not match accordingly to somebody who is looking a little different or little look alike. So that all stages will not match at one go. So that really helps. So we are building on top of that logic here. But there's a drawback in this application is you can fool this application. Like I can have Jerry Seinfeld. So if the system only works with a picture of Jerry Seinfeld for the anything, so I can fool this application by just using a mobile phone which has a picture, and then show it, and then it can be fooled. So this is not for production grade system. We can try to make it production grade system by adding some additional features to that, like you can add some liveness detection. Like you can ask in that screen that turn left, turn right. That way you can make sure that a person actually exists, or you can see a person does blinking of his eye. So if that blink is there, so also is a very good way to detect some liveness detection. I would definitely like to recommend people working in computer vision, check out the PyImage search blog by Adrian. It's really good for starters. And also refer to the OpenCV blog. I think it's Learn OpenCV. It's very good, very detailed. It's very good blog. So definitely check that out. Coming back to what we're gonna do today. So in this repository, so we have this is an Always AI project. So you have to install the Always AI and CLI tools, and then download this repository. So first thing, we have to create a data set of known people. For simplicity, so I have a Kaggle data set, which is here, which contains 5 celebrities, namely Ben Affleck, Elton John, Jerry Seinfeld, Madonna, and Mindy Kaling. So this, for simplicity, I just use this data set, and I will generate a database which will be knowing these people, and then I will use a validation set which I will use to verify the algorithm whether it works or not works. So let's get started. So first we'll download the repository, and I have downloaded the data set as well. So let me show it to you. So the data set is here. So data set has 3 directories here called data, train, and val. So data is data, train is a training data set. So for any, whenever you're working on any machine learning, you need to divide your data set into 70-30 ratio or 80-20, whatever suits. So 70% will be used for training, 30% will be used for validation. Here we are not doing any training, but still we divide the data set to generate some database of known people. So what we do is in the training folder, just copy all the folder as is and open the facial recognition, create a folder called dataset, just paste it. So next, we need to go to the validation dataset folder and copy like 2 or 3 images of each. So I'm going to copy 3 images and put it in the images folder. This is our test set. So there are some images which are not part of the data set here. So these are the people which the application or the database does not know. So I'm going to copy some more 3 images. I'm going to copy. Then 2, 3 more. Feel free if you have any questions so far. Let me know.
Yeah, at any point you can raise your hand and we can call on you, or you can just type in your question using Q&A.
So AB, some of them want to know about the core algorithm on it. They were asking whether it was AI or not, and I was telling them about shape predictors and so forth. But you might have some commentary on those and pieces, because definitely they are AI and they're trained. But go ahead.
Yeah, so we are not training any algorithm. So the shape predictor is already trained and developed.
Yeah.
So it is using the same shape predictor which we demonstrated, which Komal also shared. So basically we are extracting all the facial features. So how the eyes looks like, where's the location of those eyes, where is your nose, and what's the range of your so based on, so yeah, something called encodings.
Yeah.
So we're gonna do that. So I'm gonna cover that here when I'm gonna generate the database. So
They're also asking if we're using any type of database program down below. Not that I know of, but you
no, not at all. So I'm gonna I'm gonna generate. So there's a library called Pickle in Python, which generates a serializable kind of a blob. So which will be most of these models, whatever AI models or whatever, you can you normally call it, you put it in a pickle format, which gets loaded, and then the model can be run. So I'm using the same one. So if you go here in facial recognition folder, so we had created this data set folder, which has all the known data set of the actors. Then we went to the images folder. We added some of these images from the validation data set and put it in this folder. Now, next is very simple. You go to the scripts folder and you just issue a make command. So what it will do is, so it will just instantiate a Docker container, which will run this script called encode.py. What does this script do is just use the same library which I referenced in the start of this tutorial. It will extract these features and based on that, it will label it. So each, if you see here in the dataset folder, everything is put in a separate directory. So all these separate directories represent a person. You can even make it more interesting, that you can create a folder, say Abby, and I can put 10 or 4 or 5 images or 10 images of myself or my selfies, but make sure that it should only have one face in that picture, only my face. Otherwise the encodings would get confused. So you can have a facial recognition for myself. So,
and then what AB, I did mess up the question since people aren't asking live. It was not database. He meant to ask data set, and I think they want the link to the data set. Come on.
Oh yeah, sorry. So the link to the data
it's not
set
your
is
fault.
there in the repository.
I asked the question wrong. I didn't. He said no.
Sorry,
data
yeah.
set.
So in this repository, sorry. So let me cover this repository. What's there in the repository first? Sorry.
Okay.
So in this, so how do you use this facial recognition app? So first, as you said, we download the data set. The link in a data set is there in the repository. Just copy the train directory into the dataset folder, or you could also train your own set by using 8 to 10 images of a person and just name it as one folder. And then copy some of the images from the validation directory into the images folder for testing. So yeah, so we are in that step at the moment. So once you do that, you go to the scripts directory and just issue a make command. So what it will do is it will create a Docker container, and then it will do the installation of the same library and dlib. And then it will try to extract all the facial features of each. It will go through each and every images and try to take out all the facial features and then package it up in a pickle format called encodings.pickle. So
is it okay
let me do that.
For one more question?
Yeah.
So we have a question here that says, can we do face recognition with a face mask?
Sorry?
Is it possible to do face recognition with a face mask?
Like you wear a mask?
Yeah, yeah.
I don't think so, because then it will mess up with the facial features. So, but if you have a picture in the data set wearing that mask, for example, I want to see like how the shape predictor will detect the linings. But so what kind of mask? It will be a mask of a person, or it will be mask of an animal?
So what I think AB is, you need definitely more than a 68 point system, right? There are many that commercial ones that are 300 plus, right? 500 plus actually. And I think you might have a chance with a mask on, right? If you have more of those points to line up and so forth. But you're right. The best way is probably nowadays on the security. I'll let you go ahead and finish. If you're going the right direction, you may want to get some with the mask on, but it would definitely have to be above a 68 point system.
Of course, yeah. So there are some shape predictors which are, I think, 128 mask as well, and there's one which is more than 500, as Steve rightly pointed. Yeah, but if you want to do with mask and all, then it comes to, there's a way of, no, it will not be facial again. You can do like retina, all that pupil and all that kind of recognition comes, and yeah. And everything goes in a multi-factor authentication. No authentication system is ever based on a single base. So it will always be multi-factor authentication. So, okay, let me issue the make command. Let's see what happens. When you run this command for the first time, it will definitely take some time because it will download this Docker images and all. Since I have done it earlier, it is becoming really fast. So I will take it back a little bit to show what's happening. Okay, so what it has done is, it has done the same Docker related stuff. So it ran the script on the data set. This will be the output. And this is the way how it does the facial extraction. Excuse me. So if you go here, the files encoding.pickle gets generated. So this is your database. So this is what the program will load and then compare each of these images, the faces detected in the images, and with this. Okay. So yeah, so what we do here is we are importing the EdgeIQ library here, NumPy, CV2, and this is the pickle which I talked about. This is used to read the pickle file and load it. So that will be your data, that will be your ground truth. And this is the face recognition library. So first thing is we'll load the file, the encodings.pickle, and that will be your data. Next, we go and look for all the images in the images folder. So we are using the EdgeIQ list images library, which makes your life very easy. Otherwise, you have to write your own code to look for that. So you can put any type of images like PNG, JPG, and EdgeIQ will take care of that. Next, we instantiate a streamer for the images, and this is the time which will like each image will be there on screen and goes one by one. So we read the images. So by default, OpenCV reads the images in BGR format. So the library face recognition works on RGB. So we need to convert it using this function. Next, we try to find the location. So first we need to find where the face is in the images, and then try to extract your encodings from those face locations. So that's the one. It's like the similar thing we did for generating of the database as well. So we try to take out each and every from the data set. We take out all the facial features and then try to put that in the database. So it's the same thing. So we try to get the facial encodings for that particular face detected. And then it does, there's a library exports a function called compare faces. So what it will do is within the, it will compare the encoding with the encodings which are stored in the database. And then it will try to calculate how close you are or how much you resemble to the one which is in the database. Like for example, if two people who are bald, who are clean shaved, definitely there could be a lot of resemblance from the AI perspective, but there should be a threshold and a confidence level. This is what we are trying to do here. So this is like, we calculate how close you are to the encoding which is stored in the database. So we have a threshold set to 0.6. Um, if you see things messing around too much, then you can try to adjust that. For me, it was 0.6 was enough. So and then we try to use the numpy functions to see where distance match to the minimum distance, and then we return the ID of that, because everything gets stored in a numpy, in the form of a numpy array. So you get the index of so these names is actually the directory names, because we want to finally draw a bounding box and put a label of the person we have identified. In case the face is not part of the data set, we just mark it unknown.
All right. So let's can I stop you for some questions? I got a couple that have come up.
Sure.
I know you're in the middle of it, but a lot of questions, AB. That's a good thing. So Robert has 2 questions. Will it recognize within low lighting, poor visibility, change in skin tone? So, i.e., I have a suntan.
I believe so. It should. So definitely, it's you have to do some tweaking. So if you have pictures, if you have photographs, then definitely it can do a better job. So I was about to cover, after I'm done with this, that how this can work on with a webcam. With webcam, or it really it can struggle a bit, but you can do some tweaking with, like, you can do some batching, or even if you can process alternate frames rather than processing each and every frame, because this algorithm is not as fast as well, because sometimes can mess around, because I've tried it on in a on a what is it, on a prototype, on a frame of devices. It sometimes really messes, like if you put a lot of makeup and all, it really messes up with you with somebody else, like, who looks similar. So yeah, so I've seen that, but
Then
it
the
should
next
work
one,
pretty good. Yeah.
yeah. Then the next one, thanks on this. The next one, and I'm sorry I stopped you at the wrong places. I don't know.
No worries, no worries.
Thing on that. Robert had another one. Can it detect facial expressions and know the mood of the person? Lie detection. He was thinking about.
That's a very good. That's a very good question. So we can definitely use built on top of dlib to do emotion, your facial expression and all, because when your facial expression changes, your facial features also changes. So if you have that, like for example, when you smile, your lips are widened, right? So they change the offset of where, for a normal no expression or neutral expression. So if you can have the training done on top of that, so if you have smiley faces, I can show it to you real quick here. So
Okay.
in this dataset folder, so, but the thing is, it will only it will not identify like generic from you. So like in your dataset folder, it will have Jerry Seinfeld smiling, Jerry Seinfeld sad, or Jerry Seinfeld neutral. Okay. So you need to put all the smiling faces of Jerry Seinfeld in that folder, all the sad faces of Jerry Seinfeld in the sad folder, and neutral in the neutral folder. That way, so when you show Jerry Seinfeld's smiling photo, it will definitely identify, because you have trained the landmarks on that, because his smiling will be same, right? So it will be in that subset. So I think it's worth a good try. It's a very good question. Normally for emotion recognition or this kind of expression, mostly people use neural nets, because that's easier. uh, and there is a lot of there's a model available as well. So yeah, but it's a very great question, I would say.
Yeah, and then on facial landmarking, some retailers have used it if they see smiling and so forth, and they like to see where the eyes are looking and so forth on it. So
Case
they've
detection.
used it on that type of thing. Again, there are retail applications to using that to see what a customer is staring at when they're looking at a shelf and so forth, and whether they have a happy expression to stuff.
Yeah. So, okay. So any more questions?
We have
Yep.
like a comment from Trevor Burrow. He's saying it compares the data set with the database, then without the data set image, it has no reference. I think we maybe need more context. Trevor, is it okay if I unmute you? Okay. Maybe we can continue.
Yeah,
Okay.
sorry
Oh,
about
wait,
that.
he's on. Okay.
Yeah, it's just, you know, it's comparing a data set image. You got 5 images there in the data set, and it's comparing it with the database. So without that data set of those 5 images, it won't be able to compare anything to the database that it collected when you ran the make.
Yes.
So this program is just limited in that way. This is almost like just a training thing, because you can never really get in real life, get a data set.
Yeah, but this is facial recognition. So for facial recognition, you definitely need a known of people. Like for example, so it's like the same thing. You have a house, right? And I'm allowed in your house or not allowed in your house with the key. So you need to give me the key. So it's like that I'm registered to come to your house. So it's the same thing for facial recognition. You need to be registered in my system, and then only I can identify you for facial recognition. The facial detection is totally different. Facial detection is like you just detect faces. For that, you don't need the data set at all, which we have seen in the sample app, which Komal, so it just detects the faces because it has the points, shape predictor point system. So yeah. Am I understanding your question correctly?
No, that's correct. Thank you so much.
Okay.
Thanks,
Okay.
Trevor.
Cool.
Yeah, so it does need to, and it does sampling across faces. We all watched, at least in the United States, CSI. They go to their database to find their criminal and match up the
Yeah.
faces. But they needed those pictures of the criminals and so forth to be able to do that. So Trevor's absolutely right on that. But facial landmarking, you can detect smiles and things like that because, again, it's based on where things, you know, the face has a very symmetrical shape to it, and so it can figure out what's going on with those points. So you can, without, you know, once you have that trained system on a shape detector, you'll be able to tell whether somebody's smiling. Going back to image search, they use Adrian uses to find somebody who's nodding when they're driving, things like that. So
Yes.
So I think there's two things, but Trevor's right. You have to have a core database. It's not magic. It has to compare against something.
Yes. So without that, facial recognition is not possible. You need to have a registered data set like to compare with the ground truth. So yeah, so good questions. So yeah, so later once we do that, then it's the usual stuff. We draw the bounding boxes, and then we create a label and try to put what's the name of the person we've detected, and then we send everything to the streamer. So that's pretty much it. Let's give it a go. And this time we're gonna run it on Jetson Nano. So let's see. We create a new project, facial recognition. Yeah, here we select a remote device. In my case, I already saved my credentials, so it will pull up from that. It's a Nano. It will run in the form of a Docker container in the, yes. It will on the Jetson Nano, and we can everything be controlled from the CLI. That's really great. So I don't have to even log into my Jetson Nano. I just need to know the IP address of that. So install. So this will copy all the directories, all the files and directories from the current folder into the target thing, and it will download the Edge IQ container. Since I have downloaded that, this takes a little bit of time, and based on internet connectivity, it can take a little bit of time. So in the interest of time, for me is like, I thought of doing that earlier. Rest of the, and then it installs the virtual environment. Here, the dependencies are the libraries, the facial recognition. That's why we have additional line of installing Python dependencies. So one thing good about alwaysAI, just remember, if you want to work with any custom libraries, you just need to create this requirements.txt and just put in your name of the library into that. It will automatically take care of installing all these dependence libraries. So yeah, so let's now and then you should start. And then we go into the browser. So since this is not localhost, we have to put it in. So this is the guys who are from unknown category. So that's why they are marked unknown. And these are the guys from the known category. So it identified Ben Affleck, Elton John, Mindy Kaling, Jerry Seinfeld, the old Jerry Seinfeld, Madonna, and this is the young Jerry Seinfeld. So you see there's a variation in the age as well, but still it's able to identify that. So that is what is the demo about.
Excellent.
So that is what I had. Any questions?
Maybe I actually have a question. I think you might have addressed it earlier, but it's kind of building on top of Robert's question. If you had trained a data set with people's younger faces, do you think this would work with someone like older, like when their skin looks different?
No.
No.
If they are not part of the training data set, it will be a little different. So like sometimes you develop, so it will try that, but that we have to tweak the threshold of that. So it will try to, because your core features don't change even if you get old, but you still, like, as Steve rightly pointed, we might have to use a higher point shape predictor. That way it will have more points, and then it has more features to compare with, right? Compared to 68. So we are using the most basic one, the 68 point, the most easiest one, this is like a hello world for facial recognition. So
makes sense.
They're difficult data sets to annotate. They're no fun. So find somebody to annotate, get an intern or something like that, because you got to remember drawing like points on people and things like that with your annotation software. So maybe you can get some type of automation on that. I don't know. I haven't worked enough around those, but yeah, it's just not a very fun process. That's why I think I went to the default one in dlib.
Another thing is that it will be definitely a good, you can even convert the same program to use the camera as well. And that way you can do your own facial recognition. So there's good amount of projects as well. People have created like electric bells, like video doorbells, using this kind of application in this library. So it will be fun to check that out as well. So
amazing. Thank you so much, AB. Does anyone else have any questions? Feel free to write them out in QA or raise your hand. I know we have like about 1 more minute left, but we're still accepting questions. Okay, we have a note from Lila. She's part of our team actually. She said, "Very cool, AB. Thank you for doing this hacky hour." And let's see.
Thank you.
Trevor is asking. Well, Trevor, you might want to take this offline, but he's asking if you work contract jobs. And then Marty, the CEO of our company, said amazing demo. And then Aubrey said, great session, guys. Quick question. Yes, Aubrey, I can unmute you if it's helpful.
Hi, good evening, guys. Can you hear me?
Yes, we can.
Yes.
Okay, it's actually my first time joining in this type of session, so I was giving it a try, and it was very interesting. Understand the facial recognition and face recognition. Very good. I've got a bit of a different question. Moving objects, moving camera. So the camera is moving and the object is moving. I don't want to get into too much detail, but is there going to be another session more on moving objects? This is regarding animals and from a drone on a specific altitude, and it's not a multi-role drone, so it's a different application. So will there be a future type of session on these type of challenges where your camera is moving and your target is moving?
Certainly we can. Again, this is for the, we look at that as a request on it. And we will try to get that in with it. Now, probably be around a specific drone data set that we'd have to look in. The idea is you use an object detector on that. And it should be able to, what I would recommend on it, the approach I would probably take on it is to, you build out a detector of the animal classes that you want to detect. And you're going to need to get footage from the drone system. And then you're going to want to use also what they call a tracker technology, because again, when object detection comes back, it does at the highest confidence level and things like that. So you see it bouncing around your animals. If you have something that's moving, you want to also put a tracking, which we have in our product, but you want to accompany a tracker and pass off the thing so it smooths out the detection. But we definitely can start to. It is a subject matter that comes up. We have a company that works with it does boats. And it has to identify things on the water. So, for example, their problem is they don't want the boat to go into any type of changing course or so forth if it sees waterfowl, because the waterfowl will get out of the way, and so forth. But again, it's a they're moving objects all around it, and they have the similar challenges as drones do. And we'll take a look at that one. That's a really good idea. So.
Okay, thanks, Steve. Yeah, so it was just a quick question because currently I'm sitting with stacks of data, and we do a manual on the fly, shooting from the hip, using the human eye to detect things and to change direction, of course, from the drones and on long range. And I mentioned animals, but basically it's people, it's operations, it's vehicles, it's different types of vehicles. It's in the bush areas, it's security areas, it's utility structures. There's a lot of other things involved. So so the way I've tackled it currently is doing it manually for the last few years, and by using the operator monitor the objects, and so it's like flying live and observing, but you can miss things still. So I was just I thought there was already applications in the market, and I actually went so far as, so basically I discovered stuff at the military levels, but so then I actually walked into a wall and I discovered it's actually quite a niche market because it's not 100% solved yet. And I've been through quite a few developers where they just couldn't get to break through it. So that's why I came up to, so I keep on trying to research and develop. And my background is GIS and civil engineering, and I moved towards the drones. So I'm building electronics in the drones myself, and because of security reasons. And there is a need for this market, for this specific market, what do you call it, arena application. So so maybe I would just hook up with someone after this on a separate session privately later or whatever.
Yeah, no, it's fine to, if you go on our site and so forth, we have what we call a Discord channel where you can send an email to any one of us and so forth. We provide software tools, but we certainly can lead you in the direction and so forth. The key is creating the data set, though. And capturing that film from the drone, and then you can start doing object detection, and then train that data set. And like I said,
I've got stacks of data in video format.
That puts you ahead of a lot of people.
Sorry?
I said that puts you ahead of a lot of people.
Yeah, this data is already like 4 or 5 years old. Some of them are 6 years old. And the idea started from a few years ago, and I couldn't break through this whole thing to make it easier. So, and the more I'm scratching, the more I discover it's big challenges. But and I actually went so far as some companies in the States, and it's doing stuff on the ground. But it seems like it's easier when there is people who've got a camera on a pole and watching people walking past with their dogs or monitoring this. But as soon as you say the camera is moving and I need to track it, and I need to have a GPS coordinate, and I need to do reporting, and what time of the day this object was moving from here to there to give out reports, then it becomes the challenge. And I was quite surprised that there's nothing out there yet 100%. So maybe there are, but so anyway, I will look into you're referring to the website on the request, referring to the AI site. This
and then AB works for Accenture, and I'm sure that he might be interested too, because he's in the IoT group, and they do a lot of really good consulting work. Yeah.
Okay. Thanks, guys. It was a great session.
Yeah.
I understand 100% facial stuff. Thanks for everybody. Thanks for your time. Okay, man.
Thank you.
Thank you.
Yeah, thanks. Okay, does anyone else have any other questions? Okay, I think it's time to wrap it up. AB, thank you so much for joining and showing us this great application. And
always a pleasure. Mine. Thanks for having me here. Thanks, Steve. Thanks, Vamal. Always there to pass on the knowledge to the people.
Yes,
and again, to the community, we love to see projects, and obviously we love for them to be shared. So please, send us an email, and we'd love to have you on. So.
And reach out to me if you have any issues with any questions related to repos or something. Definitely reach out to me on GitHub or LinkedIn, anywhere. So yeah.
Thanks, AB.
You'll find me.
Yes, and definitely find AB. And if you are working on a project using alwaysAI and you want to come share with the community what you're working on, send me an email and we can set up something similar like this in Hacky Hour for you to demonstrate what you've been working on, share with the community, and just participate in the discussion and show us what you're doing with computer vision. So thanks for that. Thanks for joining, everyone. And we do this every Thursday, 2 p.m. to 3 p.m. PDT. So join us next week at 2, and we'll see you then. Thanks, everyone. Bye.
Thanks.